Okay, I'm going to show you how to solve separable differential equations and do an example. Um, let's get started. So, what does a separable differential equation look like? Well, it involves a first derivative with respect to two variables, say dy by dx, and two functions, or the product of two functions of each of those variables, so f of x, say, and g of y. These could be like any functions, you know. If you're trying to solve a differential equation and you wanna, if you wanna find out if it's separable, basically just really look for this product of the functions. If you have an equation that looks something like this, if you have like additions and like something like this when it's factorized and stuff, if you have like a plus, something like that, isn't actually separable. So watch out for that. It has to be the product of two functions if it's separable. Okay, so how do you solve an equation like this? Well, basically, or maybe not basically, you wanna get the function of y and dy on the same side, and the same with the function of x. So how are we gonna do that? We're gonna start by dividing both sides by the function of y, if it's in this like form. Which will give us something along the lines of this. And then this will allow us to integrate both sides with respect to their own variable. It kind of looks like you're timesing both sides by dx, which you can think of it that way, I suppose, but dy by dx isn't actually a fraction, so don't always, you shouldn't think of it like that, but it does actually work in this case. So that's going to lead to us having something that looks like this, which is the integral of 1 over g of y dy, and this is, I think, the blue things that we used earlier. We've put them together so that we can integrate, equals the integral of f of x dx. So you're going to have to be able to integrate both of these functions if you want to solve it. Okay, and that was the red pair. Okay, so what will our solution look like? So let's say the integral of this function is big G of y, and the solution to this is big F of x. We're going to have a constant of integration, and that is your solution. You might be able to rearrange it to make y the subject, because that's, usually what you want. You want y equals something. Although there's two integrals here, there's only one constant, because say there was a constant from this integral and a constant from this integral. Once you put them on the same side, so we move this one over to this side, this is actually just a new constant, and let's say that's big C, so it's fine to just have one constant, and that is your solution. So let's do an example. Okay, so we're going to do a simple example just so you get the gist of it, and it's going to be dy by dx equals e to the y sine x. And this one is relatively simple. As you can see, we have the product of two functions. We have our function of y here, our function of x, so we want the function of y to be on the same side as the dy, and the opposite for dx. So let's actually say this is minus y. So this is actually equal to sine x over e to the y, if you want to think about it like this. This is how I think about it. So now if you want to pair up this and the dy, you can probably see that you can just times both sides by e to the y. So that's what we're going to do. So we're going to have e to the y dy by dx equals sine x. Okay. Need to make some more space. We'll move to the side. So now we need to integrate e to the y dy, integrate sine x. So quite easy integrals. So, e just integrates to itself and sine goes this cos. And then we're gonna add our constant c. Final step, you can make y the subject by taking logs of both sides. Which will leave you with y equals natural log of minus cos x plus c. And if you might get some initial conditions which will let you figure out what c is. But yeah, that's the solution to that differential equation, and that's how you solve all separable differential equations. Thanks for watching, that's it.